All right, this is a proof from section 5.2, number 21. And looking at this proof, you're trying to determine a way to prove MO is parallel to RP. Okay, and we know 5 ways to prove lines parallel. Okay, either alternate interior angles are congruent, makes lines parallel. Alternate exterior angles congruent, make lines parallel. Consecutive interior or same side interior angles are sup, which makes lines parallel, or same side exterior or sup, makes lines parallel. And then lastly, corresponding angles congruent, make lines parallel. So those are the 5 ways we know. So looking at this, we're trying to determine which of those 5 is going to help me here. So I'm given some stuff. I'm given MOP is a right angle. Okay, I'm also given that RP is perpendicular to OP, which actually is going to give you that angle ROP or RPO is a right angle as well. Reason being, if lines perpendicular, then right angles. Because if they're perpendicular lines, then right angles. That's why that angle is a right angle. So what I could say from here, I could probably jump right in and say what I need to say. But you know, looking at these 2 lines, these are parallel basically because this angle and this angle are supplementary. Well, I need to take probably an extra step. I'll go right now. So angle MOP is sup to angle RPO. And you could explain this in one if-then statement. That's why I was able to do it in one step. So those are sup because if 2 angles are right angles, then they're sup. Right? Right angles are supplementary. 2 angles are right angles. They make 90. They're each 90. They're going to add to 180. Because those angles are supplementary, I can go right ahead and say MO is parallel to RP. Reason being, if same side interior angles are sup, then lines are parallel. Okay, 4-step proof. Number 21 from section 5.2. All right, moving along. If you want to pause this at any moment and figure out what I did, you can do that. Moving along, we got number 15 from section 5.3. So this is again a proof, but instead of proving lines parallel, I'm given that lines are parallel, and I have to prove that some other angles or sides in this case are congruent. Okay, so looking at this problem, I'm going to again mark what's given. So given that FH is parallel to JM, angle 1 is congruent to angle 2, side FH is congruent to side JM. I want to prove that GJ is congruent to HK. So looking at this problem, this is a really good proof for the mere fact that it uses a lot of the concepts that we've used throughout the first few chapters of this book. So I want to prove GJ and HK are congruent. So I'm not going to leave that as one of my marked givens, but I can leave the other things. So looking at this problem, all right, I'm going to use up the fact that the lines are parallel to say something about this problem. And what I could say is, since these lines are parallel, I'm going to extend them just to show. I could say those lines are parallel, which means these angles are congruent, because if you look at this transversal, these are alternate exterior angles. So this angle here and this angle are alternate exterior, which makes them congruent. So erasing that, I'm going to just say that in a sentence. So this angle is congruent to this angle, and that would be angle FHG. It's congruent to angle MJK. Because if lines parallel, then alternate exterior angles are congruent. Okay, so that's step 2. Step 3, I still need something in these 2 triangles, because what I'm trying to do here, if you haven't guessed, I'm trying to prove these triangles are congruent. Because if I can do that, then I can prove that GH is congruent to H to JK, which would allow me to prove what my actual goal is, and we'll show that in a second. So I still need one part, and I'm just one short step away. That is just to say angle GFH is congruent to angle KMJ by the property that we've seen a lot of but haven't seen in recent sections. But that is because angle 1 and angle 2 are congruent. The other angles are congruent because if angles are sup to congruent angles, then they are congruent. Since angles GFH and angles KMJ are supplementary to the congruent angles 1 and 2, the angles GFH and KMJ are going to be congruent. So that's why those are congruent. So now I could say this, put little marks in there. So now these two triangles, the triangles FHG and triangle MJK, are congruent because of angle side angle. All right, I got one angle from step 2. I got my side from the given, and I got my other angle from step 3. So just to check that you did all the angles, sides, and the angles that you needed, I marked this step that I could prove those congruent. So now I'm 2 steps away from proving what I want, and the first of these 2 is to say GH is congruent to JK. All right, GH is congruent to JK by corresponding parts of congruent triangles are congruent, because those are CP, CPC. So now, that's what I just said, is that this is congruent to this, and what I'm trying to prove is that GJ is congruent to HK. Well, what property is that? Pause and think about it. Very simply, it's just the additional property. So GJ is going to be congruent to HK, and that is something we've seen a lot of. That is your addition property. You added the same segment to congruent segments. I added HJ to GH and JK, and I got congruent segments. So that is the proof in 6 steps. I hope this helps. 2 questions, one from 5.2 and one from 5.3.